So we have another problem that says we have two coupled the mechanism. One is the pulley and the other one is the wheel. That is, pulley rotates with an angular velocity of the angular acceleration of 2 radians per second squared, and then it has a radius of 0.15 meters. And also the pulley B has the wheel B has a radius of 0.4 meters. The question says that find the magnitude of velocity and the acceleration of point P on the wheel, so when the pulley has turned 2 revolutions. That is the question that we need to answer. So here we will use the results of these gear meshing equations, and then we have to notice that instead of gear we have a pulley and then wheel coupled with a belt. So I can say that the velocity of A is same as the velocity of the B, or you can say that the velocity of pulley is same as the velocity of the wheel. And then for the velocity of the pulley I can write the omega A, the radius A, and then omega B, and then radius B. The radius A and the radius B, we know that, so that will be 0.15 and this one is 0.4. But the omega A and omega B is unknown, but we only know the acceleration. And then from the acceleration we can find the omega. So let's see that. Okay, so we know that alpha is d omega by dt, and then if you integrate it, so if you remember our previous equation set, so the omega was the omega initial plus the alpha constant times t, and also we have the omega is d theta by dt, and then if you integrate it you will get theta is theta initial and then plus the omega initial times t plus half alpha c the time squared. And then for the question we have the initial omega as 0, then theta initial as you can take 0, and this term is 0. So it will be that omega is alpha c times t, and then theta is 1/2 alpha c times t squared. Question says that, so here we have the t as unknown, but the question says when we have 2 revolutions. 2 revolutions means that each revolution is 2 pi, and then it will be that 4 pi radians, and that will be 4 times 12.56 radians, and this one is the theta. Okay, so I can replace theta back here. I know the alpha c and I can find the time, and at this time from here I can find the omega. Let's do that. Will be 1/2 times the 2 and then times the time squared, and that will be that time will be, and then square root of this one,
nighttime greetings to you,
and then that will be 3.54 second. Okay, and then from here I can find omega as 2 times 3.54 seconds. That will be 2 times 3.54, 7.08 radians per second. Okay, so from here I have the value of omega. Okay, and then I can put omega a here, and then I can find the omega b. Okay, and then from omega b, and then let's do that one by one. So from here, so 7.08 times 0.15, that will be omega b times 0.4. From here, omega b will be 7.08 times 0.15 by 0.4. 2.66 radians per second. That's the omega b. So we have the omega a, we have the omega b, and then the question says that find the velocity. Velocity is not easy, so that omega b into the radius b, it will give me the velocity at point p. Actually, at any point, that will be the velocity. So that velocity of the wheel will be that omega b times the radius b. And that's actually 2.66 times the same value as here, 0.4. And since they are equal, that should be equal to 7.08. I mean, the velocity is, let's do that, 2.66 times 0.4, 1.06 meters per second. And that is also the same as velocity of the pulley. Okay, that's for the first part. And then the question also says that find the acceleration of the point P. Okay, the point P, so if you remember, we have said that, so let me just add it here. This is the pulley, and then I have a point P here. This point P has an acceleration this way. This will be tangential acceleration, and this will have the normal acceleration. Okay, the tangential acceleration, if you remember, it was, so let me just go back to formula. As you can see, okay, this is the alpha into r. The normal acceleration is the omega squared into r. So that will be alpha into r. The normal acceleration will be omega squared into the r. And then first omega square r, this one is easy because everything is known. The omega is, so let me just make it as r, then r. The omega is 2.66 squared, and then times the radius, which is 0.4, and that will be 2.66 times 2.66 times 0.4, and then 2.83 radians per, the meter per second squared. Okay, that's for the AN, and then the other one will be alpha into r. And for this one, we need to find the alpha. But if you know from here that we said that the acceleration of A is same as the acceleration of these two the gears have the same acceleration. I should correct it as this one should be the tangential acceleration. Okay, because the normal acceleration will be different. The coupled part is the tangential acceleration. Okay, and then that one will have the alpha A, the radius A will be equal to alpha B, the radius B. Okay, so the tangential accelerations are the same. If I come back here, that one will be the same as tangential acceleration of the pulley. And then for pulley, I know the alpha, which is 2, and then I know the radius, which is 0.15. That will be 0.3 meter per second squared. Okay, so with this one, we found the tangential acceleration and the normal acceleration. The total acceleration will be just this by Pythagoras theorem. and that will be 2.83 times 2.83 plus 0.3 times 0.3, and then square root of this one will be 2.85 meter by second squared.